Thank you for inviting me to this event. I'm very excited to be here. This talk is meant to be a non-technical talk. So we're here today, we're talking about the Canadian AI Olympiad. We're talking about Canada's kind of introduction into this great event. But I actually want to take a step back and I want people to think about AI and AI systems. Um, from a very abstracted, broad level perspective. I want people to understand that AI is not just computers. It's not just mathematics. It's not just computers. It's not just, you press a button and something works, but it's a lot more than that. Especially when in today's world, we have a lot of excitement and also a lot of hype about deploying different types of AI systems in different types of settings. So, in my research, I often take a very deep dive into how AI systems are being deployed in public services. So, what do I mean by that? I mean by public services, I mean AI technologies in areas of the government like criminal justice, child welfare, higher education, public health, housing, so on and so forth. So any point where any common citizen interacts with the government, now there's a lot of emphasis from the government that they actually want to deploy AI systems. Many of you may know or may not also know that right now we have for the first time, a federal minister of AI in Canada. So there is a lot of push at the federal level to think about government services and AI. So I will give you a very brief story of the work that I've been doing, and this is a deep dive into child welfare. This is about how AI systems are deployed to protect against some of the most vulnerable children that we have in our society and where all of that might go wrong. So I will present the outcome of some research papers, but I will abstract that as much as possible because I do not expect this audience to grok a lot of the math with me. So this is a very abstracted presentation, but I'm very happy to go into the details with anybody at any point of time. So let's look at this. So as I pointed out, there's a lot of ways in which these types of systems are being deployed. For instance, here's a system called Pattern that was trying to make predictions in criminal justice about bail sentencing or reoffending. There was another kind of system that kind of looked at, okay, school segregation is a huge issue. It's a big issue in Canada also. How do we kind of deploy a system to make that better? And then you also have something which is in child welfare. This is what I really care about, which is, okay, can we deploy AI systems to help or protect against some of the issues that our most vulnerable children suffer from? So in general, I like to think about this type of a research approach as a human-centered approach. And it's human-centered because we're really trying to empower stakeholders. So AI system deployments makes absolutely no sense if the system doesn't actually help the people. So we have to design the system to help the people. And in addition, we have to support their decision-making processes, right? Like we have to help them and we have to improve the quality of the work. Otherwise, what's the point of having an AI system? So we kind of wrote a book a few years ago that we call Human-Centered Data Science. And what we want to do through this kind of perspective is we want to take a very structured approach to understanding how AI systems are deployed in these types of settings from a systematic perspective. So really what we have is we have systems where we really try to understand the socio-technical system. Socio-technical system means, for instance, a child welfare system is a socio-technical system. There's people, society, and then there's technical systems. So when you put the two together, it's called socio-technical system. And then you kind of need to go through a very structured human-centered design process. Don't worry if you don't understand any of these words. These are all different ways to think about design. And then you actually go ahead and develop these algorithms, and then you have to kind of test them. You have to do evaluations. It's not enough to take an AI system, throw it somewhere, and then just pretend that everything is working, because otherwise it usually doesn't. So in order to take this very structured approach, we will ask 4 questions. What do AI algorithms currently look like in child welfare? How are they embedded in the processes? Like, what are they actually doing? How can we help improve their decision-making practices? And then finally, how do we think about risk? And I'll come to that in a little bit. Now, if I abstract the math a little bit, this is what every single algorithm looks like. Whether or not it's ChatGPT or whether or not it's any other kind of AI algorithm, at the end of the day, this is what algorithms look like. There's almost always inputs, there's an output, and then there is a method. So every single algorithm can be abstracted down to these 3 component parts. And when you do that, and I'll kind of talk about these findings, essentially, when we were studying child welfare systems and we looked at, okay, what is actually being predicted, we realized, and you can see here in the red kind of marker, essentially what is being predicted is risk. Now, risk is a very interesting thing, right? So what do we mean by risk? So it's things like risk of neglect, risk of maltreatment, so on and so forth, of children. And when we kind of looked at the input, what actually goes in, we realized that what really goes in are a lot of stuff around risks as well as significant stuff about demographics. So we're trying to use demographics, which includes things like race and gender and other socioeconomic statuses, in order to predict whether or not some children are at more or less risk of maltreatment or neglect. And then when we kind of look at the methods, we realize that unsurprisingly, over a period of time, there's been a lot of focus on kind of machine learning models that are increasingly being used to kind of develop these types of systems, right? So when that happens, you see key takeaways for this. We realize that there is a need for your algorithms to be theoretical and context aware. We realize that we want to actually get the right types of data. We don't want data that's readily available and easily quantifiable. Just because we can count certain things doesn't mean that we should be using that data, because it's not very useful. At the end of the day, especially for child welfare, we should be trying to improve lives and not just minimize risk. Risk minimization makes no sense. If an AI system doesn't improve our lives, then what's the point of the AI system? So we started working with the American Civil Liberties Union, which is a nonprofit civil society organization, really big one if you've heard of them. And then we started kind of collaborating with them to understand how these tools are spreading, where these tools are currently being deployed, who is actually developing these tools, so on and so forth. So we did a lot of work. And then after doing that work, we started to ask a question of, okay, we understand how these tools are developed, but what happens when they're deployed? What happens when they're actually put into these systems? So in order to understand that, I'll abstract this a little bit. We actually studied this child welfare agency in the state of Wisconsin in the US. And this is actually what that system looks like. You can see that the child welfare system is a really complex system. It's not easy to kind of decipher where and how this system exists and where algorithms are being deployed. So when we mapped all of that out, I want to draw your attention to the text with the red boxes. There's actually different types of algorithms that are implemented in different types of different parts of the process to make sense of and to predict different things in different steps. So that's really interesting, because when people think about AI systems, they think about one AI system that is actually making decisions. That's actually not true. There are many different types of systems that are making little sub-decisions. So this actually complicates our worldview. And then as people who think about AI and who want to design AI systems, when we think about the practical deployment, we realize that it's actually a really thorny problem, because it's not a one-to-one kind of mapping of something goes in, something happens, and something else comes out. There's different types of algorithms that are deployed at different points of time. So this is just a representation of what those algorithms do. What are they actually supposed to predict? What do they predict? When do they do so? So on and so forth. So we kind of wanted to think about main takeaways. And essentially the takeaways are, that current AI systems in child welfare, their predictors, their outcomes, their methods, they're not appropriate for improving outcomes for families. They don't do anything about improving outcomes. Instead, data is intentionally biased and co-opted by caseworkers and foster parents. There's all of these stories that we learned about how the caseworkers and the foster parents who actually interact with the kids, they've realized that there is some AI system in the background there. They were never told that there's a system in the background, but actually figured out there's a system in the background, and then they kind of co-opted it so that whatever garbage is being put into the AI system, only garbage comes out. And that's one of the big issues with AI systems broadly construed. We often call it GIGO, garbage in, garbage out. And that's something key to remember as we develop our technical chops of developing AI systems, that if you put garbage in, you're only going to get garbage out. And the most important thing that I think is a big takeaway is that, the people who actually work in the system, they want to help the kids. But they can't help the kids because they think that the AI system gets in the way. They think that the AI system is not really helping them make the decision that they should be making, right? So, having understood all of that, we wanted to deconstruct this system, and we kind of tried to understand. I'll abstract. This is a lot of theory, I know, but we really try to understand how do we design better systems. And so there's all of these things around, different types of design processes, so on and so forth. And what we really wanted to understand is that, AI systems have impacts at varieties of different levels. There's an impact on practice, there's an impact on the agency, there's an impact on actual decision making. And at the end of the day, when it comes to some high risk assessment, high risk area like child welfare, where, you don't want to be wrong about the most vulnerable children in society. You want to help them do better in life. And so if an AI system does not do that, then there's a huge issue, right? Like we were then going to fail our kids. So that's what we kind of figured out. And we kind of came up with this theoretical framework to do all of this design and so on and so forth. And then we said, okay, we've understood how what the AI algorithms actually are. We've understood them, we've mathematically deconstructed them. That's like step one. And then step two is we've understood how those algorithms are actually put into the agency, how these algorithms actually work, so on and so forth, right? And now we try to understand, okay, how can we actually improve their decision-making practices, right? And so what we wanted to understand, right, and if you think back to that very first kind of question, when we studied which data goes into current AI systems in child welfare, we realized that it's all structured data. It's all of this data in this little gray corner over here. That's the data, if you remember my words, that's readily available and easily quantifiable. So it's data that's already there, it can be counted. Let's just throw that into the AI system. And then we realized that that's actually only about 15% of the data that's available. And it's not even data that's useful. So maybe we don't want to think about this gray area of the pile, and maybe we want to think about this broader blue area of the pile, which is all text data. It's all narrative data. And so AI systems making sense of text data is something that has become very, very pertinent in the last couple of years, especially with AI systems like ChatGPT and Copilot and Grok that have become accessible to the common person. But when we started doing this research, it still wasn't that accessible to the common person. So we realized that, okay, we ought to kind of use existing algorithms to kind of deconstruct the systems. And we realized that a lot of the data that's in this blue pile, that is the actual critical data. That is the data that actually things like decisions, critical decisions, circumstances surrounding decisions, uncertainties and confounding factors, all of these things that are actually important for the AI system to understand, they were never included in the design of the existing algorithm. So how do we kind of think about that? So in order to do all of that, we did this analysis. I'll abstract the analysis a little bit, but we were doing something called topic modeling. And when we kind of did topic modeling, and the way you can kind of imagine this is it's like if you put in a few documents into ChatGPT and you ask ChatGPT to build a summary for you, that's basically what topic models do. And they build summary for you. They kind of help you kind of come up with these main level, high level summaries. And what we realized, and I want to draw your attention to these two topics in the red. essentially we realized that there are things that arise from this narrative data that we never ever even saw, and nobody even talked about it, and it was never there in the existing algorithm. So we realized that some of this data that's in these red boxes are very important, never kind of put into the existing AI algorithms, and which, when we kind of went back to our collaborators, our caseworkers, and we said, are these important? They were like, oh my God, this is extremely important. For children who are in distress or who are suffering and who have like medical needs, managing medical consent schedules and appointments is extremely important. So if you don't do that, you don't do anything else. Or like doing assessments to figure out whether or not the child is progressing, right? Like what is their care plan? Are they doing well? So on and so forth. If these are never considered in an algorithm, then what's the point of an algorithm? So what we did was, and I'll abstract this analysis as well, but we were really trying to figure out what happens over a period of time, right? Is there some way where we can use an existing AI algorithm to kind of go over all of this narrative data? And they were dealing with massive chunks of data, okay? And so over a life of a case, right? And that's the kind of x-axis that you see over here. Over a life of a case, can we kind of pinpoint the really important points? So if I restate that, I'll say that, is it possible to use AI algorithms to pinpoint critical decision-making points? So this was something that was never done before. So we started to see if that's possible, and we realized, and you can kind of see in the red boxes, that it is possible. So it is possible to kind of look at critical kind of risk factors over a period of time, and they kind of come in peaks and troughs. And so in child welfare, that's usually what happens. There's usually an initial crisis, then you manage, then there's another crisis, then you manage, and it keeps going down over a period of time. It's a very typical pattern. AI is able to determine that from a whole bunch of narrative data about the case. And then you can get at like specific things like parenting assessments, right? Like there's a lot of assessments that kids need to complete, that their parents need to complete. Can you detect all of that, right? Is it possible for an AI system to detect all of that and then kind of factor that into decision making? And so we were able to detect, we were able to see that, okay, this is something that kind of works. We were able to detect that. So that's cool, right? And then finally, we were able to look at other types of things, right? Like home safety assessments. So when a child is not, they're under child protection, then oftentimes a social worker will come to the home and they'll do assessments. They'll see if the home is safe for the child, and they do that at periodic amounts of time. So you can pinpoint all of these different critical decision-making points using AI algorithms. Quite possible to do that. So if that's true, right? If all of that's true, we wanted to get a sense of whether or not we can also understand who is important for making those decisions. So we understood, number one, that we can detect when those decisions happen. But number two, it's very important who makes the decisions. Because both of those criteria are important to make better decisions in the future. So this is just an example, but here's the actual one of the empirical results. But for a particular category of groups, so this is children who are in short-term foster care, we realize, and it's this green, don't worry about the particular figure, that's a little bit more academic, but if you look at this green kind of bar, it basically shows that a foster parent makes the most decision. And that's important. If you are a kid who's in short-term foster care, then decision-making must be nudged and done by the foster parents. It's probably different if the kid is still at home but under child protection. It's probably different if the kid is with some other family member. But in this particular case, we're able to detect, using existing AI algorithms, who exercises the most power and who should be nudged to make better decisions. So that's another kind of good thing that we realize. Then, if we abstract all of that, we realize that, number one, it is possible to use AI algorithms to detect when critical events and key decisions happen in this like really complex environment, right? This environment is not simple. It's extremely messy, extremely complicated, but we can detect when we want to make these decisions. And number two, we're also able to detect who makes those decisions. So these two factors are very important. So finally, we realized that, okay, we started out with this presumption that, okay, there's a lot of existing AI algorithms that are focusing on risk in child welfare, right? Risk of a child, risk of maltreatment, risk of neglect, risk of abuse, so on and so forth. We realized that these existing AI systems don't actually predict risk. They don't actually do the prediction that they're claiming to do. So how do we make that better? Well, in order to make that better, right, we need to understand what actually risk is and whether or not we can detect and kind of define what that is with an AI algorithm. So here's the basic problem. Predicting risk inherently is problematic because risk is a nebulous construct, right? Because there's a temporality to risk, right? Like this risk is not like a static thing. It goes up, it comes down. It's like this very temporal dynamic thing. And then people are also not silly and don't stand around doing nothing. When people realize that there might be some risk, this risk, a child is at risk of something, then they try to do other things, which are called protective factors, to try and calm that down, to try and like mediate that. This is what people do in reality, not over computer systems. So, how do we build AI that kind of accounts for all of this? In order to inform of the decision making, in order to help the decision making in situ means on the ground. So so again, we kind of did a whole bunch of analysis. I'll abstract this for a moment. There's a new algorithm that we're using, but this is the big picture that I am really, really interested in. So for a bunch of cases, right, we were kind of looking at these risk factors over a period of time. This is real data, right? Like everything that I'm showing you is actual data from child welfare. Nothing is simulated, nothing is made up. It's real life, messy data. So you can see that for like a certain type of cases, there are peaks and troughs when it comes to risk. So risk starts out pretty high, then it kind of goes down, then it comes up, then there are spikes, right? Like maybe a child is engaging in some type of risky behavior or some other things, and then it kind of usually it's supposed to go down, as that you can see here when the case ends. So this is like an accumulation of some cases from June 2019 to December 2021, and we're trying to kind of look at all of these things. The thing is, we can detect these risk factors that happen, and then we layer the protective factors over them. Because, see, this is what happens in reality. Caseworkers and parents know that a child might be engaging in some risky behavior, and then they do things that are called protective factors that I mentioned in order to bring that risk down. And you can clearly see here that the protective factors kind of act as a little guard against the risk. If this green peak was not there before this red peak, then this red peak would be even higher. It would be even more problematic. So we can use AI systems to detect that things that people do actually result in a shortening of the red peak. We can detect all of that. And you can kind of see that in a variety of different cases. Now, when we add other types of factors, like systemic factors, maybe the child happens to come from a broken family or they happen to come from a very poor background, these are always there. These are in the back end. There is nothing that AI systems can do that account for systemic factors. They're always there. That's why they're called systemic. And improving AI systems will never touch any of this. For that, we need to do other things. But then there's also these things called procedural factors in the yellow, which are things that that government does in terms of process to protect against that. And that also has a little minor type of an event. So when we kind of take all of these things together, we realize that it is possible to use AI systems to not just detect when risky events happen, but to also detect how the protective factors protect against increase in spike of the risky events. So if that's true, if we're able to pinpoint those things from historical data, then we should be able to design systems that actually preemptively, proactively kind of make suggestions or help caseworkers and foster parents to make better decisions. And so this is a pictorial representation of the interplay between all of these factors. Here's some big takeaways, right? So the main thing that I want everybody here to leave with is that when we have an AI system that's deployed in these like high risk kind of decision making environments, we need to understand that risk is not static, but has is both temporal, dynamic, and also process situated. Things that people do affect that risk. And this is something that existing AI systems that predict risk, which by the way is all around us. So City of Toronto is using various types of approaches in its different agencies like housing, homelessness, so on and so forth. Health Canada does similar things with diabetes prediction. Children's Aid Society Toronto is trying to do similar things with, their children, so on and so forth. So everything that's here is also real here in Canada. This is not like some exercise in futility, right? We see these examples all around us. And so, what are the big takeaways then, right? Like, so, we can understand what those AI algorithms are. We can understand what happens when those algorithms are kind of put into the system. We can then use better AI systems to detect when and how and who should be factored into the better decision making and design of those systems. And finally, we can do better than the existing predictive risk models. And so we kind of come back to this systematic human-centered data science approach that I presented. And now you can see that I've kind of filled in the gaps with these prior research papers that kind of do all of those things. So this shows you that, if we take a very systematic a systematic approach to kind of deconstructing and unpacking existing AI systems, then we can also use that systematic approach to design better AI systems that actually helps the people on whom the AI systems are being deployed. And so I will kind of abstract over all of this, and then I will leave you here right at my allotted time. Thank you very much. Hope all of you learned something useful. Greatly appreciate this, and happy to take questions if there's time.
Okay. Thank you, Professor Guha, for the interesting talk on what is the human-centric AI and how these techniques can be used for the public policy decision making and also the risk prediction. Actually, we have collected maybe two questions from the audience. Yeah. Maybe I guess it's a more general questions, not technical part, I guess. So the first one is, how do you view the phenomenon of using the GPT to cheat?
How do you view the? Oh, yeah. Actually, I just talked to that's a really interesting point. I just talked to a reporter from CBC about this. Students are often trying to use ChatGPT or other products to kind of cheat in the classroom. What you don't understand is that if you try to do it with computer science professors like me, then you're going to get caught, and then you're going to get fail in class. So it's a big issue because in my classes, for instance, I always tell people you can use ChatGPT, you can use it to do your assignments, but you have to credit exactly how you used ChatGPT, where it helped you. You cannot use ChatGPT to just like replicate everything, right? Like we should not be under any illusions that people won't use ChatGPT. Everybody uses ChatGPT, even in nowadays in software developers are using ChatGPT. They call it vibe coding, right, to actually code software products. So people will use it. So in the classroom, we actually have a lot of ways to detect it, and we know exactly where you detected it, how you detected it, and we do employ it. We do it at U of T all the time. So, it's a I don't think that it's like black on white. I think that we have very good policies for how to use ChatGPT in the classroom, but it has to be kind of done well. You cannot just like copy paste stuff and then expect that you're going to do well. They don't. Every year I get students increasingly who fail, and then they come crying to me. I'm like, no, it's not going to work. uh, and then I see another question. What is the relationship and difference between studying computer science and studying AI? Yeah, that's actually a very good question. This is something that we debate in our department all the time as well. So computer science AI is like one part of computer science, right? Like computer science includes a lot of other things that traditionally we might say it's like there's theoretical part of computer science, there's databases, there's programming languages, And then, AI and machine learning, that's one part of it. Human computer interaction, that's another part of it. So one of the issues in just studying AI is that it forces hyper specialization. And I'm not making a value judgment and saying that is that a good thing or a bad thing. I'm just saying that the difference between studying computer science and studying AI is that if you're only studying AI, you're becoming a hyper specialist in AI. But if you're studying computer science, then you have a lot more broader knowledge in computer science. And this is something that at U of T, that even amongst the professors, we debate this a lot, right? So we have programs that are just masters in AI program, and people there don't learn a lot of the other parts of computer science, which they may not need to learn, but they should understand that it's a generalist versus specialist kind of approach. And then I see another question, right? What is the most challenging part of my research on AI? I'll tell you the most challenging part of my research in AI. The most challenging part of my research in AI is actually incentivizing people to use AI properly. So AI that is not designed well uh, will also not be used well. And people, you can design any system and you can let people use it. And you might have a vision for how the system is supposed to be used, but people are going to use the system in all kinds of different ways. When ChatGPT kind of came out, GPT-2, GPT-3 kind of came out, nobody expected that people would be vibe coding to develop software GPT-4 onwards, right? Like I have seen, once I saw in downtown Toronto, I saw this guy in a coffee shop, and he had like Gemini and ChatGPT and something else open, and he was giving the same prompt to all of the systems, and it was a coding prompt, it was a vibe coding prompt, and whichever prompt worked, he would copy paste that into his actual work. Like this is not a student, this is an actual person who was doing software development. I went and I asked him, like, what are you doing? Like, how are you? Like, nobody ever thought that we would be using it like this, but people are going to use it in all types of different ways. So the most challenging part is actually figuring out how people are going to use the system, because we can, as computer scientists, we can design the best ever AI system in the world, but if moment we give it to people, people are going to use it in all kinds of ways. And you cannot force anybody to use an AI system in the way that you actually want them to use. So that's the most challenging part. How do you actually, what is that difference? And this is something that computer scientists took a little bit of time to understand, that you design a system, but then people are going to use the system in some way. And there's a difference between these two things. And that studying that difference is really interesting. Last question. How should I start learning AI? Well, if I hear that some high schools nowadays are starting AI programs, but honestly, the best way to start learning AI is not just to jump into some, free MOOC or something like that. The best way to study AI is actually to do it in a very structured and systematic way. So you are actually not going to learn AI very well unless you have a good, strong background, right? Like base has to be very strong. And that often means that you have to study some math. You have to study some math very well. You have to study some programming very well. And this is something that I see students nowadays, they don't want to do, right? Like, oh, what do you mean we have to do like 3 semesters of calculus and then one term of linear algebra and one term of probability and statistics before we start introduction to AI? Can you not just teach me some AI just like that? I was like, no, because then you're not going to learn AI. You're going to learn how to use AI systems. But learning how to use AI systems and learning AI are two separate things. And I always encourage my students to take the whole thing and do it in a very structured and systematic way.
Okay, okay. Thank you for Professor Guha.
Thank you.